Welcome to today's free webinar by Elemental Science. All right, my name is Paige Hudson. I'm the author of the Programs of Elemental Science and co-author of the Science Education Philosophy book entitled Success in Science, a Manual for Excellence in Science Education. We'll be giving away a printed copy of Success in Science at the conclusion of this webinar, so you'll want to stay tuned till the end. Today's webinar will be based on the Science Fair Project, a step-by-step guide, which I also co-authored with Bradley Hudson. We're going to look at the steps of the Science Fair Project in detail, and then we'll give you an opportunity to ask any questions you may have. If you do have any questions along the way, feel free to type them into the chat box and we'll answer them as you're able. Is everybody ready to begin? So, why should you do a Science Fair project with your students? Well, all students need to have the scientific method demonstrated repeatedly for them, and by the time they have graduated, they need to have utilized the process over and over again until it has become a natural habit. I've learned through my teaching and research experience that to truly understand science, one must be familiar with this fundamental concept. As homeschoolers, we tend to skip over the Science Fair project because it appears daunting. But in reality, it's an excellent tool for giving our students hands-on experience with the scientific method. The Science Fair project is a meaningful assignment that we can use with our students to increase their understanding and familiarity with the scientific method. So when should you do a Science Fair project with your students? Well, the students doing a Science Fair project should be able to read fairly well on their own. They should also be able to summarize what they have learned from reading several paragraphs of nonfiction material. They should be starting to learn how to apply what they know to a new situation that is before them. This is why we recommend beginning to do a Science Fair project with your students once they are in 5th grade. Once the students reach the middle school years, we do consider that the Science Fair project is an essential component of an excellent science education. These students need to experience the scientific method from start to finish in a real and practical way. And this assignment will help you to provide such an opportunity for them. The science-oriented high school student can continue to do a Science Fair project, but it's not a necessary component for all high school science curriculum. In Success in Science, we talk about 2 different tracks for science education in the high school years, the knowledge-building method and the science-oriented method. The science-oriented students are ones who desire to major in a science-related field, such as medicine, engineering, architecture, and the other sciences. They should have a curriculum that will prepare them for the rigors of college-level science, as well as give them a strong foundation for their future careers. A beefed-up version of the Science Fair project will help you to achieve this. So what exactly is the scientific method? Well, in a nutshell, the scientific method trains the brain to examine and observe before making a statement of fact. It is the main method that scientists use when asking and answering questions. Using the scientific method will teach your student to look at all the evidence before making a statement of fact. The steps of the scientific method are, number 1, ask a question. The scientific method begins with asking a question about something that is observed. Number 2, do some research. Next, the scientist needs to learn about the topic from the question so that he will have some background knowledge about the topic. This will keep him from repeating mistakes that have been made in the past. Number 3, formulate a hypothesis. A hypothesis is an educated guess about the answer to the question. The hypothesis statement must be measurable and answer the original question that was asked. Number 4, test with experimentation. The experiment will test whether or not the hypothesis is true or false. It's important for the test to be fair, so this means that the scientist may need to run multiple tests. Each time, only one factor is changed in the experiment so that he can determine which factor is actually causing the difference. Number 5, record and analyze observations or results. During the experiment, the scientist will record his observations and measure his results. Once the experiment is complete, he will analyze all the data to see if his hypothesis was true or false. Scientists often find that their hypotheses are false. If this is the case, they will formulate a new hypothesis and begin the process again until they're able to answer their original question. And finally, step method is to draw a conclusion. Once the data has been analyzed, the scientist can make a statement about what he found, and this statement communicates his results to others. So when you teach your student to use the scientific method, it will train their brain to answer questions they have in a logical manner. It sounds a little intimidating, but it's really not. You're simply teaching your student to take the time to discover the answer to a given problem by using the knowledge they have, as well as the things they observe and measure during an experiment. So let's take a look at the science fair project. In essence, this assignment is an in-depth experiment which will take several weeks to complete. The science fair project follows the steps of the scientific method from start to finish, plus 2 extra steps for sharing their work. The 8 steps needed to complete the science fair project are: Step 1, choose a topic. Step 2, do some research. Step 3, formulate a hypothesis. Step 4, design an experiment. Step 5, perform the experiment. Step 6, analyze the data. Step 7, create a board. And Step 8, give a presentation. Once a school year, students in 5th grade or higher should complete a science fair project. The first time they do this, you will need to thoroughly explain each step and coach the student through the entire process. They will need you to work alongside of them from the time they formulate their question until they polish up their conclusion and presentation, so that they will learn the process correctly from the beginning. As the students become more familiar with the scientific method, they will be able to do more of this project on their own. It's also important to have the students present their project to a group and answer related questions from them. This will reinforce what they've learned, as well as help them to discern how to communicate what they know. The best way to achieve this is to have the students participate in a science fair, such as Kirklick's Earth Day Science Fair for homeschoolers. So let's take a closer look at Step 1, which is choose a topic. The first key to complete Step 1 of the science fair project is to decide on an area of science that interests the students. The students should choose an area that fascinates them, something in science that they want to know more about. Because if they're fascinated by the topic, it will be much easier for them to complete the project, and they will be more likely to engage with the material that they are learning. You will begin by leading the students to brainstorm about things in science that interest them. Have them rank these areas by degree of interest. Then have them choose one area to focus on. If their area is too broad, you want them to narrow it down a bit. You can do this by asking them what they found interesting about the particular subject. Once the students have determined their area of science, you can move on to the second key. They need to develop several questions about the subject that they can answer with their project. Good questions begin with how, what, when, who, which, why, and where. Say to the students, now that we have determined an area of science you want to learn about, let's think about some questions you would like to answer about the subject. At this point, you're just getting them to think of possible questions that they could use for their project, as you will be narrowing these down in Key 3. So once the students have several options of questions that they can answer with their science fair project, you need to have them choose one of those questions for their particular assignment. Some of their questions will be easy to develop into an experiment that will determine the answer, and some will not. If you think that their question is too broad, you will need to help them narrow it down to something more specific. It's important to note that the students may need to tweak and adjust their topical question as they proceed through the next steps. They may find through their research that they need to be more specific, or they may discover as they design their experiment that their question needs to be a little less specific. Their question remains a fluid topic until they begin their experiment. In Step 2 of the Science Fair project, the students are going to do some research. This step of the Science Fair project begins with the students brainstorming for categories to research. This is an important key because developing relevant research categories before they begin to search for information will help the students to maintain a more focused approach. It will also help the students to know where to begin their research and how to determine what information is important to their project and what is not. It's an important organizational tool that you should not skip. You will need to guide your students through the brainstorming process just like you did in Step 1. Keep in mind that younger students may have a harder time coming up with categories, so you may need to give them additional assistance. A student should have at least 3 categories and no more than 5. This will help them to obtain relevant information as well as make it easier for them to write their report. Once the students have chosen their research categories, have them assign each category a number before moving on to Key 2. Now that the students are ready to begin their research, depending upon their experience with fact-finding, you may or may not have to walk them through this entire process. Either way, have the student begin by looking at the reference material that you have close at hand, such as encyclopedias that you own. Then you can have them look at their local library or on the internet for additional information. Typically, a scientist would also look at scientific journals that publish research articles, but that will probably be a bit much to expect from a middle school student. Plus, they will likely be repeating an experiment that scientists have already done, so it's best for them to focus on gathering important information on their topic. I generally recommend that students record their research on an index card. So, as the students uncover bits of relevant data, it's best to have them write down each fact on an individual card. Each card will contain only one fact that relates to the student's research categories. In the upper left corner, the students can write the corresponding research category. Later, the students will use these categories to organize their information into a research report. In the upper right-hand corner, the students will write the letter that they have assigned to the specific reference. This way, after they organize and sort their cards, they will still know which references they need to include in their bibliography. The students will gather a lot of information from their research, and it may seem like a waste of index cards, but it's important that they follow this procedure as it will help them to organize their research. So now that we've covered Key 1 and Key 2 for Step 2 of the Science Fair project, let's move on to Key 3. Once the students have finished their research, you need to have them organize and sort through this information that they found. Begin by having the students sort their cards into piles using the research categories in the upper left corner of their index cards. Then, have the students read through each fact and determine 5 to 7 of the most relevant pieces of information from each of these piles. You will need to help them as they decide which facts are relevant to their project. You want facts that are useful for answering their topical question, not the ones that aren't. These facts will then form the basis of the research report. The final key to the second step of the Science Fair project is to have the students write a brief report in which they share what they have learned. This report should be 1 to 2 pages in length and should contain roughly 3 to 5 paragraphs. This will be an easy task because the previous sections have prepared the students for it. First, have the students determine the order they want to share their research categories. Normally, they would go from broad information about the subject to more specific information for their project. After they do this, they will need to take 5 to 7 facts from the first category and turn it into 3 to 4 sentence paragraphs by combining the facts into a coherent passage. They will repeat this process until they have a 3 to 5 paragraph paper. Then, the students will need to edit and revise their paper so that it becomes a cohesive report. Finally, they will need to add the bibliography with the resources that they used for their research. This research process may take several days to several weeks, but don't rush this process as it's key for preparing the students for Step 3 of the Science Fair project. Step 3 of the Science Fair project begins with the student reviewing their research. You want the information that they've learned to be fresh in their minds, especially since several weeks may have passed since they wrote their report. You can do this by having them read over the report or by having them read each of the index cards that they made. The level of involvement for this key will depend upon how much time has gone by between the steps. After the students have reviewed their research, they should also read over the question one more time. Once all the information is fresh in their minds, they are ready to make an educated guess at the answer to their question. This is also known as the hypothesis. The hypothesis is normally a simple if-then statement that is no more than 1 sentence long. The students must be able to test the validity of the statement. so that they can measure whether or not they have obtained the answer to their original question. Using an if-then statement for a hypothesis makes it easier for the student to create an answer and verify. However, keep in mind that not all questions can be easily answered with an if-then statement. As they design their experiment in the next step, you can still have them make a few adjustments to their hypothesis and to their original question if you find it necessary. Step 4 of the science fair project begins with the student brainstorming for possible ways to test their hypothesis statements. You can ask them, what kind of test could you use that would answer your question and prove if your hypothesis is true or false? Have them write down each idea that they have, but keep in mind that the students may need a fair amount of help with this process. If the students find that they cannot come up with any options for testing their hypotheses, they may need to tweak their statement a bit. If they decide to do this, make sure that they re-verify that the new version still answers the original topical question. Once the students have written several ideas down, have them review the options and choose one of the ideas for their projects. If your students are really having a hard time brainstorming ideas for possible tests, you can use the internet to research science fair project options within their selected topic, or you can check out one of Janice Van Cleve's science fair titles for optional tests. So now that the students have chosen a method to test their hypothesis, they need to determine the variables that will exist in their experiment. There are 3 types of variables at play in any experiment: independent variables, dependent variables, and controlled variables. Let's take a closer look at the definition of each of these 3 types of variables. So the independent variable is a factor that is controlled or changed by the scientist in an experiment. The dependent variable is the factor being tested in the experiment. The dependent variable is what the scientist uses to measure the effect of the changes on the independent variable. In other words, the dependent variable depends upon the independent variable. The controlled variable is a factor that is not being examined in the experiment. The scientist will keep the controlled variable constant so that their effects on the test will be minimalized. So once the student understands the difference between the types of variables, they will need to determine the factors that are at play in their own experiment. You can have them answer the following questions to help them see what their variables are. What factor are we trying to test? This would answer the independent variable. What factor will we use to measure the progress of our test? This will measure the dependent variable. And what factors do we need to keep constant so that they will not affect our results? And this will give you your controlled variable. So after the students have answered these questions, have them write down their independent, dependent, and controlled variables. Middle school students should have only one independent variable and one dependent variable in their experiment. So now that your students have chosen a test and determined the variables, they are prepared to move on to Key 3, designing an experiment. They can now use this information to create their experiment design. You need to explain to them that they must have a control group as well as several test groups. The control group will have nothing changed, while each of the test groups will have only one change to the independent variable. The students should also plan on having several samples in each of their test groups, which assures a more accurate result. Once you have explained to the students the parameters of their experiment, they will begin to formulate their plan by determining what their test groups will be. Then they will need to decide how long they have to run their test. Once they have this information, they can write out their plan. Once they have their experiment design on paper, the students need to go back and make sure that their test will prove their hypothesis true or false. So you will need to ask the students to read over their statements and their plan. Ask them, if you got such and such a result from your experiment, would it prove your hypothesis true or false? You may have to ask this type of question several times to verify that their experiment design is sound. You do not need to have them read over their topical question again because you've already verified that their hypothesis will answer it in the previous step. So once the students have verified experiment design on paper, they're ready to move on to step 5, performing the experiment. At this point, the students already have a plan in place, but there still are a few things they need to do before beginning their experiment. They need to look at a calendar and make sure that they will be home for the duration of the trial so that they can make their observations and record the results on each day of testing. The students also need to gather and prep any materials that they will be using during their experiment. Key 2 of performing the experiment is where the fun of the science fair project really begins. The students have done a lot of work to reach this point, but that preparation has paved a smooth road for their experiment. At this point, they're familiar with their research and their design, so they should be able to carry out their testing with little to no help. Before beginning, you want to make sure that the students write down a list of things that they need to check each day during the experiment. Be sure that they include taking pictures of what they see during their experiment on this list, as they will need these images for their project board later on. As the students run their experiment, they need to compile their observations and results. It's important to note that at this point, the students are not interpreting the results of their experiment. The analysis and interpretation of this data will be done in the next step. For now, they are simply relaying and recording information on what has happened during their experiment. So let me take a moment to explain the difference between observations and results. Observations are a record of the things the scientist sees happening in an experiment, while results are specific and measurable data that he records during the experiment. Observations are generally recorded in journal form, while results can be compiled into tables, charts, and graphs. You need to help the student create a table to record the results, as well as provide them with a journal for their observations. Once they finish their experiment, you may need to help them chart or graph their data. So now we're going to look at step 6 of the science fair project. During their experiment, the students recorded their observations and measured their results. And now is the time for them to analyze this information to determine if their hypothesis was true or false. To do this, you need to have them read over their journal entries and note any trends in their observations. You also need to have the student interpret charts or graphs that they created from the last step and write down any information that they are able to glean from them. Once the students have noticed trends in their observations and interpreted information from their results, they are ready to move on to Key 2, where they will use the data to answer their question. They need to first determine if they have proved their hypothesis true or false. Generally, if a scientist finds that his hypothesis was proven false, he'll go back and perform more tests before stating the answer to his original question. However, the middle school student undertaking the science fair project does not need to do this. If your students find that their hypothesis has been proven false, simply have them note that in their conclusion. Once the students have decided if their statements were true or false, they can craft a one-sentence answer to their original topical question from step 1. Their statement should begin with, "I found that," or "I discovered that." This is because they need to qualify that their answer still remains a scientific theory, not a proven fact. In the rare case that the students are unable to state an answer to their question, they need to take what they've learned and go back to the drawing table and redesign their experiment. So, what is the difference between theory and fact in science? To answer this question, we must examine the origins of the words themselves. The word theory comes from the ancient Greek word theoria, which means a looking at, a viewing, or beholding. So in science, a theory is an analytical tool used for understanding, explaining, or predicting cause for a certain subject matter. The word fact comes from the Latin word factum, which means a thing done or performed. In science, a fact is an objective truth that can be seen in nature or confirmed through repeated experimentation. So, we can say that theories are meant to be tested through experimentation and observation to determine if they are facts, while facts are truths that can be verified through repeated experimentation or by consistent real-time observations. So in the first 2 keys of step 6, the student organized their data and stated their answer to their original question. Now, in key 3, they're going to write out the conclusion from their experiment. When the students draw their conclusions, they are putting into words what they have learned from their project. Their conclusion should include the following information: the answer to their question. Our hypothesis was proven true. Remember, if their hypothesis was proven false, they should state why. They should also have any problems or difficulties that they ran into while performing their experiment, anything interesting that they discovered that they would like to share, and finally, ways that they would like to expand their experiment in the future. It should be one paragraph or about 4 to 6 sentences in length. You can have the student begin their concluding paragraph with a statement that they wrote in the previous key. So once the students have detailed what they have learned from their experiment, they're ready to move on to step 7, create a board. The 7th step of the science fair project is not patterned after any step of the scientific method, but rather it gives the students a chance to graphically communicate what they've learned from their project. Their board will serve as a visual aid for their science fair presentation, so it's important that it be eye-catching and attractive. Since the science fair project board is a visual representation of the students' hard work, you definitely want them to put in as much effort into this step as they have into the others. The board will have specific sections that are set, but they should personalize the look with color and graphics that suit their tastes and match their projects. They should have a large center section with 2 smaller flaps on either side so that the board will be able to stand on the table and they can display it as they give their presentation. For this key, the goal is to have the students plan where they are going to put their information, what color scheme they're going to use, and what graphics they will like to use to highlight their project. They will prepare and revise their information in key 2. So let's go over the presentation board itself. The students could certainly mix things up a bit, but be sure to remind them that their information needs to be placed in such a way that it's easy for someone to follow. So the left section of the board typically has the introduction, which includes their question and a brief explanation of why they chose the topic. The hypothesis, which is their educated guess from step 3, and their research, and this is usually the report that they wrote in step 2. The right section of the board typically has their results, which includes the trends from their observations and the interpretation of their results. It also contains the conclusion, which is the concluding paragraph that they wrote in the previous step. The center section of the board typically has a list of their materials and supplies that they used in the project. Their procedure, which gives a brief explanation of what was done during the experiment, and any pictures, graphs, or charts from the experiment. If you have a student with a highly visual project, you can place the materials and procedures section on the right flap instead. The student can also display a portion of their project or a photo album with pictures from their experiment on the table in front of their board to add a little bit more interest. For the second key to step 7, create a board, the students need to type the information up and choose a font and font size for their board. This will be easy because they've done a lot of preparation up until this point. So for the introduction section, the student should turn their question from step 1 into a statement. Then they should write 2 or 3 sentences explaining why they chose that specific topic. And they should end their introductory paragraph by sharing the exact questions they were trying to answer. For the hypothesis section, they just need to type up the statement that they created in step 3. For the research section, they just need to type up and prepare their research report for their project board. For the materials section, they just need to type up a list of the materials they used for their project. For the procedure section, the student will need to revise their experiment design that they wrote in step 4 so that it's written in the past tense. For the results section, the student should turn the trends and observations that they noted and the results they interpreted in step 6 into a cohesive paragraph. And for the conclusion section, they just need to type up the concluding paragraph they wrote in step 6 for their project board. So now that the students have planned out their project board and prepared the information, they're ready to pull it all together for key 3. They need to cut out the decorative elements and glue them onto the backboard. Then they need to print out and cut out their informational paragraphs. For at a desk, they could possibly glue these paragraphs onto foam board before adding the information onto their project board. Finally, the students should add their title and the finishing touches to their board. This title can be the student's question, or they can make up a new title that reflects the purpose of their experiment. Once the students have finished their project board, they're ready to move on to Step 8, give a presentation. So, this Step 8 is the final step of the science fair project, and this phase is also not patterned after any step of the scientific method, but instead it gives the students a chance to communicate with an audience what they have learned from their project. For Key 1, the students should prepare a brief 5-minute talk about their science fair project. This talk should include the question they tried to answer, their hypothesis, a brief explanation of their experiment, the results, and the conclusion to their project. You will need to guide the students as they turn their informational paragraphs into an outline for their presentation. This outline should highlight the main points that they want to cover. Once the students have finished preparing the outline for their talk, have them practice in front of a mirror. They should practice looking at the audience while pointing at different sections on their project board. Once they feel confident with their presentation, have them give a practice talk to you. Be sure to give them feedback so that they can make necessary changes before they present their science fair project. It's also important to have the students present their work to an audience and answer related questions from this group. This will reinforce what they've learned, as well as help them to discern how to communicate what they know. The best way to achieve this is to have the students participate in a science fair where their project will be judged. But if that's not possible, don't skip this step. The students can still present their project to their family or to a group of peers. So, thank you all for listening to this lecture based on our book, The Science Fair Project, A Step-by-Step Guide. In addition to the information presented here, the book leads you through a sample project along with explanations. It also details how you can increase the difficulty of the science fair project for a high school student and contains sheets to use with your student in each step. You can purchase the ebook from Elemental Science for $5.50. Thank you all very much for participating in the very first Elemental Science webinar, and we look forward to doing more in the future. Have a great evening.